Mathematics 1 of 12th standard, which consists of algebraic part, and the algebraic part consists of the chapter matrices and determinants. This is quite easy part. It helps in the scoring in the exam. Just you have to understand it and the practice. So these matrices and determinants consist of different subtopics like order of matrix, types of matrices, equality of matrices, operation of matrices. This operation of matrices is like how we can add two matrices or even subtract, or even we can multiply the two matrices that we see in the successive lectures. Next is transpose of matrix and its properties. Next topic, symmetric and skew symmetric matrix, elementary operation of matrix, invertible matrix, inverse matrix. This inverse matrix also, it's an important topic. Next subpoint is expansion of determinant, properties of determinants, area of triangles, how to find the minus and cofactors of particular element, adjoint and inverse of matrix, applications of determinants and matrices. This application of determinants and matrices consists of topics like how we can solve the linear equations. We know linear equation solving methods we studied in the lower classes, but specifically in this topic we are going to study how we can solve by using the matrix methods. So this matrix method is also very important, and previously they had asked these questions on this topic specifically, and in the future also they may ask you. So this all the topics we are going to cover in these two lessons particularly, because matrices and determinants were combining together since they are very related to each other. So the combining them will give the exact idea of this topic, which is inside the algebraic part of your mathematics 1. The next subtopic we're going to start is the order of matrix. So this order of matrix basically signifies the number of rows and columns specifically for the matrices. Now to understand it better, we can see this example. Now you can easily look it out. This is the example I have given here for your better understanding. This example consists of horizontal array and the vertical array. Like horizontal array, that's elements are arranged in the horizontal way. That's you can see here 1, 2, 3. This is the first horizontal array. It is also called as a row. And 1, 4, 7. This is the vertical arrangement. It is called as column. So if you look it out, there are 3 horizontal arrangements and 3 vertical arrangements. That indicates this particular matrices consist of 3 horizontal rows and 3 horizontal columns. So easily we can note it out. 3 horizontal rows and 3 vertical rows signifies the order of this matrix. That means the order of this matrix is 3 by 3. So 3 by 3 means this 3 indicates, first 3 indicates the number of rows, that we know it is 3, and the next 3 indicates the number of columns, that means vertical arrangement, like we can see here easily, first, second and third. So these are the 3 vertical columns and 3 horizontal rows. So you can understood this particularly vertical and horizontal arrangements indicates the order of the particular matrix. Subtopic is position of elements in a matrix. In the last topic we studied how this number of rows and columns affects on the order. So here also at the bottom I have written 3 by 3. That indicates there are 3 rows, that means horizontal arrangement, and 3 columns, that means vertical arrangement. The significance of this order is again one more, that's like 3 by 3 arrangement. It means it consists of 9 elements. 3 into 3 is 9. So this matrix should consist of 9 elements. So 1, 2, 3, 4, 5, 6, 7, 8 and 9. So by looking into the order of the matrix, we can easily understand how many number of elements will be present inside the matrix. Now this every element has specific position. Like suppose if I talk about 1, so this 1 indicates the position in the first row and the first column. So I can say A 1 1. This small a means it's not any specified one, but since it's a notation I have taken, because I represented this matrix as a capital A, so since I have taken the small a here, that's up to you, you can give anything to it. So this is A11, that means this first one consists of row in which it lies, and the second one consists of the column in which one lies. So this one has a specific position A11. So likewise we can find this position of every element which lies inside the matrices. Like suppose randomly I'm taking 6. Now if you look to the 6, it is in the second row, first row, second row. So this 6 lies in the second row. And if I talk about the column, first column, second column and the third column, so it lies in the third column. So for 6 I can say A 2 3, that means 6 lies in the second row and the third column. So simultaneously if I say about 8, 8 is in the third row and the second column. Third row means what? First row, second and the third one. So this 8 lies in the third row and simultaneously it lies in second column. How? 1 and the 2. So this 8 lies in the second column. So position of A is in 3 and 2. So this is how we can locate the position of every elements which lies in the matrices. So the next is types of matrices. First type is column matrix. That means the matrix has only columns. So this is only one column it has, so it is called as a column matrix. Next type of the matrix is row matrix. You can see easily just one row, so we can call it as a row matrix. Next is square matrix. So square matrix means it has equal number of rows and equal number of columns. Like suppose if I count it, first row, second row and the third row. So 3 rows basically this matrix has, and first column, second column and the third column. So it has 3 columns and 3 rows. So if any matrix consists of 3 rows and 3 columns, we can call it as a square matrix. Next type of the matrix is diagonal matrix. So in diagonal matrix we can easily understand, just look into this example. This is called diagonals. So these diagonal elements 1 2 3. So only diagonal consists of some elements, but except this diagonal all elements are 0. So this diagonal elements, it may be the same elements like here is shown 1 1 1. So all the elements are 1, or diagonal elements may be different like 1 2 3. So that is not the case in this one. Just we should have the diagonal elements, except diagonal elements all the elements would be 0. If in such case we can call matrix as a diagonal matrix. Next type is identity matrix. So in last square matrix and diagonal matrix we have explained the square matrix should have the equal number of rows and equal number of columns. Even diagonal matrix should have the diagonal elements, but except diagonal elements all elements should be 0. Now if you see to the identity matrix, it look like identity matrix, but here is one compulsion, that your diagonal elements should be 1. All elements should have the value of 1. If the value is not 1, then we can't say this matrix as a identity matrix, so we can signify that matrix as a diagonal matrix. So then again, so the difference between the square matrix, diagonal matrix and the identity matrix, for identity matrix the condition is the diagonal element should be 1, and it is not such for the diagonal matrix. So identity matrix should have the diagonal elements 1, and the condition for diagonal matrix is not such. Next is zero matrix. So zero matrix means we can easily understand all the elements should be 0. Equality of matrices. So in this topic, the name itself indicates equality, means the equality between the corresponding elements in the matrices. To understand it better, we can just look into this example. Here to the left hand side we have one matrix, and to the right hand side also we have one matrix, and you know that this x plus 3 has specific position in the matrices. Even every element in the matrix has some specific positions and equally to the right hand side matrix. Now this x plus 3 has specific position as a11 because it lies in the first row and the first column. So for this element we have to see which element is corresponding. That means in the right hand side 0 has a position of a11. That means the position of this and position of this is same. So we can easily equate these two elements. We can do this only when there is an equal to sign between these two matrices. If the equal to sign is not there, we can't equate it because that is not the equality of matrices. In the exam, if they are given by equality of matrices, then easily we can equate the corresponding elements and we can find the respective variable values. Now see to the solution. As I said, x plus 3 can be equal to 0. So I have just equated here x plus 3 equal to 0. This is plus 3 here. If it comes here, becomes minus 3. So x is equal to minus 3. So I got the variable x variable value. Similarly, z plus 4 corresponding position element is 6 because that is a12. Here is also a12 position. So z plus 4 is equal to 6. So this take the 4 to the right hand side. So z is equal to 6 minus 4 and 6 minus 4 is 2. So I got the z value as 2. Equally 2y minus 7 is equal to 3y minus 2, and then you can equate and you can find the value. So I got y is equal to minus 5. Similarly, the position of b minus 3 is a 3 1. That means this b minus 3 lies in third row and the first column. So here the position of this and this is we can equate it. So b minus 3 is equal to 2b plus 4. So by equating again and interchanging, we can got b is equal to minus 7. Next is to find the c value, the position of 0 and position of 2c plus 2. These two elements have the same positions respectively in the respective matrices. So 2c plus 2 is equal to 0, I can say, and easily I can just take this 2 here. It will become 2c is equal to minus 2 and then divide by 2, and then you will get the c is equal to minus 1. So this is a subtopic. Sometimes they ask for 2 marks questions or to check your knowledge. So equality of matrices means if they are given or provided with equal to sign or something condition that by equality of matrices or something they ask in the question, you can solve the question by using this basic steps. Sometimes they ask in the exam, you construct 3 by 4 matrix. This is a matrix later they are given, and this matrix is Aij. This A means individual element, I stands for row, J stands for column. So we have to construct the matrix by using this equation. They have provided some equation in the question itself. To find the element, they have given this some mathematical form, 1 by 2 mod of, this is mod actually, minus 3i plus j. So don't consider this as bracket, this is a mod sign, this vertical line. So, and they ask you to find construct the matrix of 3 by 4. 3 by 4 means we should have the 3 rows and the 4 columns. So whatever the answer we are going to find out, that matrix should have the 3 rows and the 4 columns. So just we'll note it down. So to understand you better, I have just find out the matrix here, which consists of 4 columns and 3 rows. So 4 columns and 3 rows. This is no need to write in the exam. If you are perfect with this, then no need to write this one. Directly you can go to the equations and find out all the elements. So first element in the first row is a11, second is a12, a13 and a14. So this is our first row. For second row, first column elements means a21, a22, a23, a24. Next is a31, a32, a33, a34. So by using 3 by 4 this condition, I have just noted down this matrix. That means the first element, this is first column, second column, third column, fourth column. So this is 4 columns and 3 rows. That means first row, second row and third row. So I have to find the value of each element in the matrices by using this equation. How? Now I will just write down the equation what they have given in the question. So it is 1 by 2 mod of 3i plus j. Previously slides I have just explained this. I means row and j means column. So this is, suppose I have to find the value of a11. So I value is 1 because it's row and j value is 1. So in place of I just put 1, in place of j just put 1, and then find out the value. So here I have just did it. A11 is equal to half mod of minus 3. I value is 1 because I am finding A11. So 3 into 1 plus 1. So if I find this one, it is minus 2. But remember, this is a mod. So mod means whatever the values, negative values, will just become positive. So it is 1 by 2 into 2. So I got A11 value as a 1. Simultaneously, you have to find the value of A12, A13, A14. Just this first number is just I value, and second number is just column value, and that values you have to substitute here and simultaneously find the values of all the elements. For the reference, I have given all the values here. You can just, when you solve this one, just take the reference of this. Now in the last slide, we have found out all the values and this respective values. Just try to know all the values with his A11 position. So find out, just note it down, what is the value of your A11. Just write down it here. A12, A13, A14. All the values, whatever you have calculated, just write it down, and that will be the answer for your question. So in this way, we can find the matrix of any order, 2 by 3, 3 by 2, whatever it may be. We can easily find out by using the conditions they have provided in the question. Next is operation of matrices. Operation of matrices means we can add the two matrices, even we can subtract the matrices, or even we can multiply the matrices. So addition of matrices is very easy. Now I have given these two matrices, A matrix and the B matrix. The position of root 3 and 2 is equal position. That means this is also A11 element, this is also A11. So similar position elements we can add. So root 3 plus 2, just arrange like this, A plus B, so first matrix, and B is a second matrix. And for your understanding, I have just written the position of every element. So you will get it key what exactly which element you have to add in which one. So root 3 position is A11, 2 position is 1 1. So this element and this element I can add. So while writing the answer, I can write root 3 plus 2. So this is the element, you got it after addition. Now this is 3 I can add with this element, because this is 2 3 position. This is this will be 2 2 applied. So this is 2 2 position, this is also 2 2 position. So we can add 3 plus 3, it will be 6. So we can add this one. This is again, it's 2 3, second row and third column. So this element I can add with this element. So 0 plus 1 by 2, 0 plus 1 by 2, I will get the 1 by 2 answer. So in this way you can add the elements, but remember one thing, that every element will be added up to the equal positions only. You cannot add the randomly. Just look at its positions and add the simultaneous position of each elements. So similarly, this is same fundamental for the subtraction also. Just instead of addition, you have to subtract the elements. The next example, they are given two matrices A and the B, and the condition is 2A minus B. This 2A minus B, remember, see here, this 2 is multiplied to matrix A, and this is the scalar multiple. Scalar means is the constant value. So indirectly they are saying this 2 you have to multiply to the matrix A. So same thing we'll do it, just we'll note it down the condition here in the solution. So 2A minus B means 2 into matrix A. So 1 2 3 2 3 1, this is our matrix. It is the order of this matrix is 2 by 3. So while multiplying the 2 with respect to this matrix, we have to multiply the 2 to the every element. That means 2 into 1 is 2, 2 into 2 is 4, 2 into 3 is 6, 2 into 2 is 4, 2 into 3 is 6, and 2 into 1 is 2. So after completion the matrix, this as it is, write it down. And then as we discussed in the last example, the position of 2 and the position of 3 is same. So we can subtract the 2 and 3. So 2 minus 3 is minus 1. 4 minus of minus becomes plus. So 4 plus 1 is 5. 6 minus 3, will be 3. 4 minus, and this minus become plus, so 4 plus 1 is 5. 6 minus 0 is 6, and 2 minus 2 is 0. It's pretty easy. So in this way we can solve the sums. Just we have to see to the conditions given in the question. Next is properties of matrix addition. We basically knows from the lower standard, from the 8th onwards, what is property of commutative law, associative law, existence of additive identity, existence of additive inverse. I'll just explain quicker. Suppose this A and B are the two matrices. Then if I add A plus B or B and A, then there is no change in the answers, because whether you add A plus B or B plus A, answer is going to be same. That means these matrices follow the commutative law of addition. Associative law, then again 3 matrices we have to consider, A, B and C. So first you add the A plus B, and then to the answer you add the C. And the next condition, you add the B plus C first and then add the matrix A. There is no change in the answer. Answer is going to be same. So if this satisfies, then we can say this matrices, a matrix A, matrix B and matrix C, satisfies the law of associative addition. Next is existence of additive identity. That means this any matrix and zero matrix. Zero matrix means in the previous slides we have explained all the elements are zero. So if any matrix we add it to the zero matrix, or any zero matrix added to the particular matrix, anyways your answer is going to get the same matrix. In such cases we can say it is additive identity. Next is the existence of additive inverse. So this is matrix A, and this is a negative matrix of A. That means whatever the signs of elements of the matrix A are going to be negative, because it is called the negative matrix. So if I add any matrix and negative of its, the answer is going to be zero matrix. So such property is called the existence of additive inverse. Next is multiplication of matrices. Now they are given the matrix A, I cross J, this is the order of the matrix, and B, Mn to N, this is also order of matrix. This I, J, Mn, no need to confuse about the notation. This is the most preferred notations in respect to your books of CBSE or State Board or CIE or whatever. So next one, we'll see how we can multiply the two matrices. For matrix, remember there is one condition. We can multiply the two matrices if number of column in the first matrix should be equal to number of rows in the second matrix. Suppose this matrix has 3 columns, then the next matrix should have the 3 rows. That means number of columns of one matrix should be equal to number of rows of second matrix. If this condition satisfies, then proceed for the multiplication. Now the same thing I will explain here. Just look into the order of this matrix. This is 2 by 3, that means it has 2 rows and 3 columns, and the order of this matrix is 3 by 2, that means it has the 3 rows. Like first row is 2, 7, second row is minus 1, 1, third row is 5, minus 4. So it has 3 rows and 2 columns. So what I explained here, number of columns of first matrix should be equal to number of rows of second matrix. See here, number of columns of first matrix, how many columns are there? 3, because second number indicates the columns. 3 columns, and how many rows here? 3. That means the columns of this matrix is equal to rows of this matrix. If this condition is satisfied, then you can just proceed to the multiplication of matrices. This is quite a tricky topic. You need a little bit practice for this. See, while multiplying the same matrices I am multiplying, the first row and first column I have to multiply. Again I will explain. First row and first column. So first row and first column I multiply. So first element of first row and the first element of column. So 1 into 2 is 2. Now second element, minus 1 into minus 1 is a plus 1. So 2 plus 1. This is 2 into 5, third element, because these are all third element of row and third element of column. So 2 into 5 is 10. Since we are multiplying with the row, first row to the first column, I will get the first element in the row. So 1 into 2 is 2, minus 1 into minus 1 is plus 1, 2 into 5 is 10. So this is my first element. Now first row to the second column, if I am multiplying, I will get the second element. So 1 into 7 is 7, minus into 1 is minus 1, 2 into minus 4 is minus 8. So since I multiplied to the second column by the first row, I will get the second element of the row. So 2 plus 1 plus 10, 13, 7 minus 1 minus 8 is minus 2. So I got the first row element. Now same procedure we can follow for the second row. Second row, first column, second row, second column. So if I multiply with the second row with the first column, I will get the first element of second row. And if I multiply with the second row and second column, I will get the second element of the second row. Now we'll multiply. 0 into 2 is 0. So I have written here. 3 into minus 1 is minus 3. It's minus 3. 4 into 5 is 20. So 20. So I got the first element of the second row because I am multiplying with the second row. Now second row and the second element. Sorry, second column. So 0 into 7 is 0. 3 into 1 is 3. And 4 into minus 4 is minus 16. So I got the second element of your second row. So first row is already we have calculated, and second row. So 0 minus 3 plus 20 is 17, and 0 plus 3 minus 16 is minus 13. So in this way we can easily multiply and find the address. Similarly, the properties like how we had explained in the addition, there are some properties in the multiplication too. See, multiplication of matrices may follow the commutative law or may not follow the commutative law, depends on the type of matrices. Next is when the associative property, yes, it does follow the associative property. Distributive property, when A bracket of B plus C, it will be AB plus AC. And when you multiply with the C, it will become AC plus BC. So it is just theoretical part, but note it down, they will give the condition in examination and just you have to verify it. This is important one. If you multiply any unit matrix, that is I, unit matrix means identity matrix, that is 1 0 0 0 1 0 0 0 1. If you multiply identity matrix or unit matrix to any matrix, your answer will be the same matrix. This is a property, please note it down because it will be we require this is as a reference for the next topics. So transpose of matrix is converting the rows into columns or column into rows. Like how we can do is just see to this example. This is a matrix they have given. The order of this matrix is 3 by 2. That means this consists of 3 rows and 2 columns. So 3 5 is the first row, root 3 1 is the second row, 0 minus 1 by 5 is the third row. So A transpose, like how we can write down like A and this dash on his head, or AT, whatever you can represent. So this 3 5 is a row, I will convert that into column, means I will write like 3 5. Second row is root 3 1, so second is root 3 1. 0 minus 1 by 5, so I can get 0 minus 1 by 5. So what I did is all the rows I converted in terms of columns. If I do like this is called the converting the respective matrix into the transpose. So transpose is a very simple fundamental. Just convert rows into columns or columns into rows, your choice. I mean, better you follow one so it will not be confused to you. So first row, first column I converted, second row, second column I converted, and third row, third column I converted. So in this way we can convert the transpose of matrix. Now properties of transpose of matrix. If I take the transpose of transpose, that means A transpose transpose, I will get the original A matrix. If I multiplied the any scalar means any constant number, 2 3 4 5000 2000 whatever it may be, if I multiply to matrices, it will be the scalar into transpose of that matrix. A plus B transpose, I can easily write down A transpose plus B transpose. I can just remove this brackets, and if it is multiplied one, AB bracket of transpose, it will be B transpose and A transpose. The proof of this one we'll see in the successive lectures. Next topic is symmetric and skew symmetric matrices. Symmetric and skew symmetric matrices is like, suppose I am taking the matrix A, if I found out the transpose, after changing into transpose also, if they both have the same elements at same respective positions, that means A is equal to A transpose, then we can call it as a symmetric matrix. In skew symmetric matrices, they will have the same elements at same respective positions after converting into transpose, but the signs of the elements will be different. So if suppose, for example, I can say the element in A is 2 at A12, so element in A transpose in skew symmetric matrix will be -2. That means is what? The element will be same, positions will be same, only signs will be different. If signs are different, then we can say it is a skew symmetric, and if signs are same, positions are same, that means everything is same, then we can call it as a symmetric matrix. Next, sometimes they ask you find the sum of symmetric matrices. So we can, this is the identity, just remember, I mean just this kind of formula. So 1 by 2 bracket of A plus A transpose, if you find out, that will be the sum of symmetric matrix. Next is sum of skew symmetric matrix. As I told you, signs are different, so negative sign is coming here. 1 by 2 A minus A transpose. This on depends on this, we'll see one sum. Express the matrix B, the B matrix they have given here, as the sum of symmetric and the skew symmetric. So sum of symmetric means we know that half bracket of A plus A transpose. That means A, so it is a B plus B transpose. That means B matrix we have to add in the transpose of this. So I have added up B matrix plus transpose of B matrix. B matrix is here. B transpose means what? Row into column, row into column, row into column. So first row into first column, second row into second column, third row into third column. So this is the B and the transpose of B. So first add B and B transpose. So I have added up into half. So half into this, you can even write down the answer like this, but it is always good to convert it into proper manner. So 1 by 2 into this matrix, that means this 1 by 2 or half will get multiplied to every element inside the matrix. So half into 4 is 2, half into -3 is -3 by 2, half into -3 is -3 by 2, in such a way that you can get the final answer. So in this way we can find the sum of symmetric matrices. Sum of skew symmetric matrices, same thing, everything is same, just for skew symmetric matrix you will get the minus sign in between them. So instead of B plus B transpose, I will do for skew symmetric is B minus B transpose. So B minus B transpose, 2 minus 2 is 0, so I got 0, minus 2, minus of minus 1 is plus 1, so minus 2 plus 1 is minus 1, so find out like this and multiply that with the 1 by 2. 1 by 2 means this is 1 by 2 into 0, it's 0, minus 1 into 1 by 2, so minus 1 by 2, so this will be the final answer after simplification. So in this way you can find out the sum of symmetric matrices, even the sum of the skew symmetric matrices. Next topic is invertible matrices. See, sometimes they will ask you examine whether the given matrix is invertible or not. So what does exactly mean is, suppose A and B are two matrices, and if I multiply the AB, I will get the answer as an identity matrix, or BA, same, AB or BA, whatever, it's a commutative property. So it's identity matrix. Now actually this B matrix is the inverse of A matrix. That means if I find the inverse of A, that will nothing but the B matrix. So matrix into inverse of itself, if I multiply it, and if I am getting the answer as identity matrix, then the original matrix is called the invertible matrix. I will explain again. If I multiply A and B, and if the answer of this AB is coming identity matrix, that means 1 0 0 0 1 0 0 0 1. Actually the second matrix, that's B matrix, is the inverse of first matrix, and if this matrix and inverse of it, if I multiply and if I getting the answer as identity matrix, then the original first matrix is called the invertible matrix of B. So in this one, A is the invertible matrix. This is the condition. Sometimes they will ask whether this matrix are invertible or not. Just you have to multiply the matrix and inverse of it, and if you get the identity matrix, that is the invertible. Next is inverse of matrix by elementary transformation or operations. So see here, elementary operations means you can use the row operations or column operations, but you can't use both in the same sum. Whether you have to start the sum with the row, otherwise you have to start the sum with the column. So if you start with the row, continue till the end with the row, and if you start with the column, continue with the column itself. This topic is very important, remember, because this topic, most of the sums, long as the sum, they will ask for every successive years. For the better understanding, I have given one sum here. Remember, inverse we can find by two ways. This is the first way we can find the inverse is by elementary operations. I have given the matrix here. A is equal to 0, 1, 3, 1, 2, 1, 2, 3, 1. These are the matrices I have given, and I have to find the inverse of matrix. First of all, just note it down, this identity. A is equal to I. So in such a manner we have to write down. So A means this matrix equal to I means identity matrix. So 1 0 0 0 1 0 0 0 1. You know that, and A as it is. So one thing what we can say is, remember here this matrix I have to convert as a unit matrix. Unit matrix means what? This matrix I have to convert in terms of 1 0 0 0 1 0 and 0 0 1. That means first element should be 1. So this element should be 1, and below two elements should be 0. Then in the second column, first element should be 0, next element is 1, and next element is 0, and next is two element is 0, and last element is 1. So this matrix is going to be identity matrix. That means I have to do something so that the first element start with 1. So what I will do is, this R2 and R1 I will interchange. That means this R2 will go here, R1 will go here. So if I interchange this one, if I do something to this matrix, the same thing you have to do it here. That means your R2 is coming in place of R1, or R1 is going in place of R2. Same thing you have to do it here. So same thing I did. This R1 and R2 are interchanged. So this is R2, it came to R1 position, and this was R1 came to R2 positions, and similarly same thing I did to the right hand side. So now see here, 1 2 3 0 1 2 3 1 1. These are the three rows. So first element here is a 1, but since I want this unit matrix or identity matrix, I want this also 0, because 1 0 and 0. Now this element I have to make 0. Then again, that means which row I am changing? I am changing the R3. So R3 changes 2. So I have to do some calculation so that this element will become 0. So how we can do it? If I multiplied this row with 3, and then I will minus from this one. That means R3 minus 3R1. That means you have to multiply the 3 to the R1 and minus from the R3. So here 3. So 3 into 1 is 3. So 3 and 3 minus, then our answer will come the 0. So similarly do it here. Now if I multiply here is 3, so 6, 1 minus 6 will be minus 5. Now here 3 into 3 is 9, 1 minus 9 is minus 8. This R2 will be same as it is, because I am not doing anything to the R2. According to our assumptions, I am just doing the calculation with respect to R3 and R1. So what I did here, just multiplied the 3 to the R1 and minus from the R3. Now I got 1 0 0. So here what I want, 0 1 0. That means this element should be 0. But remember, while making it 0, nothing should happen to this element, because again if you do some calculation here and then again here changing, there is no use of then this step. So be careful. Whatever the first column you got, it should not get disturbed. So 1 0 0, that's what first column. This element also 0 I made it. How? R1 minus 2R2. That means multiply the 2 to the R2 and minus from the R1. So 2 into 0 is 0. So 1 minus 0, 1. So nothing has happened to this one. Now multiply 2 here. 2 into 1 is 2. 2 minus 2 is 0. So I got 0 here. Multiply 2 here, 4. So 3 minus 4 is minus 1. So minus 1. Same thing, whatever you do here, the same thing you have to do it here. So by using this one, I made this element 0. So 0, 1 and 0. So now anyhow I want this element as a 0. So how we can make it? I will multiply R2 with the 5, then add with the R3. So 0 into 5, 0, 0 plus 0, 0. So nothing is going to change here. 5 into 1 is 5, minus 5 plus 5 is 0. So I got what I wanted. 5 into 2 is 10, minus 8 plus 10 is 2. So accordingly, and same thing you have to do it to the here. So I got 1 0 0 0 1 0. So these two columns I got completely. Now here I want 0 0 and 1. So first element I want 0. So how we can do? See, for R2 I will divide with the 2. So if R2 I divide with the 2, then I will get, sorry, it's not R2, it should be R3. So what I will do is, for R3 I will divide with the 2, so I will get 0 0 1. So same thing, if you are dividing here this R3 as a 2, same thing you have to do it here. Okay, so now I want 0 0 and 1. So now here R1 I am going to change R1 plus R3. So after dividing R3 by 2, what we can do is, this matrix is going to change into 0 0 and 1. Now here I want 0, that means this and this I can add. If I add this and this, here will I get the 0. So R1 changes to, that means this row is going to change. How? R1 plus R3. So 1 plus 0 is going to be 1, nothing changes. 0 plus 0 is going to be 0. 1 minus 1 is going to be 0. So I got 0 here. So remember, whatever you do to the addition or subtraction, whatever to the left hand side, same you have to apply to the right hand side also. Now next one, 0 I want 0 here. This is the only last step, remember, we have to do to make it 0 here. So now R2 changes to R2 minus 2R3. That means for R3 I have to multiply by 2 and then minus from the R2. So here after multiplying 0, so nothing is going to change to this and this positions. But if I multiply 2 here, 2 into 1 is 2 and 2 minus 2 is going to be 0, so I got 0 here. So now after doing all calculation, look at to this. This matrix, normal matrix, I have converted into the unit matrix. So my problem is over, and whatever the answer coming here after doing all the calculations, this will be my inverse matrix, because A into A inverse is equal to I. That means this is indirectly the A inverse matrix. So after getting the unit matrix to the left hand side, whatever the matrix you are getting with A, that will be your inverse matrix. So this is nothing but your answer, because A into A inverse is equal to I. So this is I, this is A, so this should be definitely A inverse. So A inverse is equal to this matrix. So in such a way, we can find the inverse of matrix by using the elementary transformation. So the next subtopic is expansion of determinant. So this is determinant part actually. So this is determinant they have given here. Remember, determinant just two lines, horizontal lines you have to draw. It's not like brackets here as in the case of matrices. So this is matrix sign and this is the determinant. This 3 by 3 determinant actually, so it will have 9 elements, 1 2 3 4 5 6 7 8 9. The position of this element is 1 1 1 2 1 3. You know all these things because we have explained in the previous slides. So this is a position of particular elements. In matrices we cannot expand, but one quality in the determinant we have is we can expand the determinant. So we can expand a determinant along the first row, second row, third row, or first column, second column, or third column, whatever they have given in the book or in the exam. So on this topic we are going to solve the many sums, so that also will get clear in the next lecture. We will solve many sums on this. Just I want to tell you how we can expand. Now see here, the way how we can expand, minus 1 to the power of 1 plus 1. I am expanding the determinant along the first row. First element is 1 1, that means this minus 1 is going to be same. So minus 1 to the power of 1 plus 1. So first row and first column, 1 plus 1 into Element is what? A11, determinant of. Now how it comes here? This element is coming in this column and this row. So this we have to leave this row and leave this column. Remaining elements will come inside the determinant. So what I did? -1. This is for always. -1 to the power of 1 plus 1, because 1 plus 1, into element bracket of leaving the column and the row in which that element lies, determinant of these 4 elements, plus same thing, -1 to the power of 1 plus 2. Why 1 plus 2? Because this element lies in the first row and the second column. So 1 plus 2 into that element, determinant of. Now this column and this row we have to leave. So element will be this and this. So A21, A23, A31 and A33, plus last element of row is A13. So -1 to the power of 1 plus 3. So 1 plus 3 into element A13, determinant of. So I have to leave this row and leave this column. So this and this. So A21, A22, A31 and A32. So this is expansion of determinant along the first row. This way it looks a little bit confusing, but once we see the problems it will be easy. So for better understanding, I have given the problem here. So they are given the evaluate the determinant, that means expand indirectly. So 124 is the first row, -130 is the second row, 410 is the third row. Same way this, so along the first row, that means I will consider the first row element. So 1 lies in the first column and the first column and the first row, so it will be 1 1. So -1 to the power of 1 plus 1 into element, that's 1, into determinant of remaining element except his columns and row. So if I leave this column and leave this row, 3 0 1 0 will be the determinant elements, into -1 to the power of, this is first row and second column, so 1 plus 2 into element, so 2, determinant of leaving this column and leaving this row, so -1 0 4 0, so -1 0 4 0, plus -1 to the power of 1 plus 3, that means because this is 1 3 element, 1 plus 3 into this element 4, determinant of leaving this column and leaving this row. So elements are -1 3 4 1, so this we can write down. So now here -1 to the power of 1 plus 1, so -1 to the power of 2, that means even power, so it is going to be 1. This is now how to solve this determinant. Actually you have to multiply this and this, and we have to minus, that means 3 into 0 is 0, minus 1 into 0 is 0, so 0 minus 0 is going to be 0 here. So 1 into 0 anyhow is going to be 0. Now here 1 plus 2, so -1 to the power of 3 is -1, so minus sign will come here, this 2 will be as it is, -1 into 0 0, minus 4 into 0 0, so 0 minus 0 again 0 here, plus 1 plus 3 is 4, so -1 to the power of 4 will be 1, so 1 into 4 is 4, here -1 into 1 is -1, minus 4 into 3 is 12, so -1 minus 12, it will be -13, so -13 into 4 will be -52. If I solve this one, I will get the -52 as the answer. So the next topic is properties of determinants. Properties of determinants we'll explain today, and the successive next lecture will take the problem on this. So I'm not taking problem on the properties because you should get the time to look to all the properties and collect the knowledge about it, so that when I'm explaining to the next lecture, you will get easily what I want to say. So the properties of determinant, the first property is the value of determinant remains the same, unchanged, if its rows and columns are interchanged. That means is what? Suppose A determinant I have taken. If I find the determinant value by expansion, same thing, 2 into bracket of leaving this column, leaving this row, 0 4 5 minus 7 are the elements will come in determinant. So 0 into -7 is 0, so 0 minus 20, because I have to multiply this, 0 into -7 is 0, minus 5 into 4 is 20, so 0 minus 20 will be -20, and 2 I have to write down here. Similarly, remember this is a 1 2 positions, so minus 1 to the power of 1 plus 2 3, that means it will come minus. So minus of minus is plus. To remember is easily, for middle number, whatever the sign the middle number have now, the same opposite sign to it, take it. So instead of confusing minus 1 to the power of 1 plus 2 or something like that, just whatever the sign of middle number is coming, just take the opposite sign of it, so it will be easy. So 3 here minus 3, so I took it plus 3 here, bracket off. Now leaving this column, leaving this row, so 6 4 1 and 7 are the element. So 6 into minus 7 is minus 42 and 1 into 4 is 4. This minus sign because the two elements I have to minus. Next is plus 5, so leave this column, leave this row, so 6 0 1 5, that means 6 into 5 is 30 minus 1 into 0 is 0. So we can expand like this way and then calculate and write down what I told it here. Instead of going into the fact that minus 1 to the power of 1 plus 2 or 2 plus 1, whatever it may be, instead of this, just do one thing. Whatever the middle number is coming, for this number in 3 by 3 matrix, if it is a minus, take it plus, that's all. So it will be easy to expand it. Now this is the answer for matrix A. Now if I take the transpose of it and if I solve, again answer is coming minus 28. So matrix and its transpose, if determinant and its transpose, if I find the answer for both, the answer will come same. That means first property is clarified. The value of determinant and its transpose, if I expand, the value of both will be same. Now remember this, just see to this determinant I have given. I have expanded a determinant, the answer is coming minus 28. Expansion method is again same. 2 here and 2 is coming in this row, this column, this leave this both. The elements are 0, 4, 5, minus 7. Then we have to multiply this 2. So 0 into minus 7 is 0. And then we have to multiply this. 5 into 4 is 20. I have to minus this both. So 0 minus 20 is minus 20. Minus 20 into 2 is minus 40. Now here in the last example also I said middle number sign is minus 3. So instead of calculating, just take the opposite sign. So it will come plus 3. Bracket off. Leave this column, leave this row. Now elements are this, this, this and this. So 6 into minus 7 is minus 42. Minus, because multiplication of this and multiplication of this we have to minus, so minus will come here. 1 into 4 is 4. Plus 5. Leave this column, leave this row. So elements are this, this, this and this. 6 into 5 is 30 minus 0. So 30 minus 0 will become 30. Simplify it, you will get the minus 28. Now interchange any two rows. Now what I did it here, remember these two rows I have interchange, means R3 becomes R2, R2 becomes R3. So this is what I have done. So if I interchange any two rows or any two columns, whatever, then if I expand it after interchanging, the answer is coming 28. Without interchanging, answer was minus 28. After interchanging, answer is plus 28. That means we can infer from these two methods, if I interchange any two columns of matrix or any two rows of matrix, the answer of the matrix will be same, but just sign will be opposite. So second property is verified. So the next is property 3 of determinant. So it's a pretty simple property. Just look to this determinant. The first column is 3 2 3, next is 2 2 2, and next is 3 3 3. First row is 3 2 3, 2 2 3, and the third one is 3 2 3. Now this row, that means your R1 and R3 are identical. So identical means same. So in case they are provided with determinant and any two rows are identical, no need to solve, answer is of the determinant directly 0. For the confirmation, I have just expanded for you people. You just look into this and expand it and check whether answer is coming 0 or not. So this is basically properties required when we have to solve without any kind of expansion. In the exam, if you look into the determinant and if you found out any two rows or any two columns are identical, that means elements or respective same positions are same, then the answer of determinant is directly, you can write as a 0, no need to expand it. Next is property 4. If you expand a determinant and suppose your answer is x, for example, and then what you do is you will multiply the determinant with any constant number, suppose k, to every element or every row or every column, whatever it may be, or row or column, then the answer of determinant also will get multiplied with the k. That means previously without any multiplication your answer was x. So after multiplying any constant number to row or column, your answer also will get multiplied with the same scalar. That means your answer was x. After multiplying, your answer will be kx. This is what the fourth property. Just remember it. When we solve the sums, you will get the better idea about the fourth property. To understand by using matrices given here. Now this is the first determinant. Determinant. This first row, second row, third row. Now second row, they are given in terms of addition: a plus 2x, b plus 2y, c plus 2z. If in case any column or any row is given in such a way by the addition of numbers, then we can split it. That means your first column will be a x, second b y, and c z. So this is what the first determinant. The next one is a 2x x is what here, b 2y y this here, and c 2z z. So the single determinant I can split into two if they are given in terms of addition form. So these are the properties of determinants. So the next one is property 6 of determinant. Suppose a determinant they have given, and is the b1. In the b1 there is change. What they have made it is, if I multiplied any constant to the third row, suppose k. So if I multiplied kc1, and if I add this after multiplying kc1 to the first element of the first row, similarly kc2 to the second element of second row, and kc3 is the third element of third row, then after addition I will get the determinant like this. Even after adding the scalar multiple of third row with respect to the first rows, the answer of determinant will not change. So the answer of original determinant and determinant after multiplying the scalar to the third row elements and adding to the first row elements, the answer of both the determinants will be the same. Now next topic is the area of triangles. The problems on these properties we'll do in the successive lectures. So just after the lecture you just look into all the properties, just study it well, understand, and so that the next lecture when I post it, so you'll get exactly the idea what I'm going to say. Next is a very pretty simple chapter or subtopic, area of triangle. Suppose this is triangle they have given, x1 y1, x2 y2, x3 y3 are the respective coordinates of this triangle. Area of triangle, how to find out, in the lower classes we studied, but basically since we're studying about determinant, I should know how we can find the area of the particular triangle they are provided with coordinates. So if even the question comes in the exam, find the area of triangle, or the points are collinear, some conditions they will put it, we'll see in the problems better. With respect to this triangle, the a coordinate is x1 y1, b coordinate is x2 y2, and c coordinate is x3 y3. So we can write the area of triangle is kind of one arrangement. Suppose area is equal to half determinant of the first coordinate was x1 y1, so I can make the first row x. Next very important topic, finding the minus and cofactors. This is quite important. So directly we'll see by taking one example. So this is determinant I have given. So we have to find the minus and cofactors of all the elements. All the elements means a11, a12, a13, a21, a22, a23, a31, a32, and a33. So first, 9 elements. So we know that the order of this matrix should be 3 by 3, and the 3 3s are 9. So this matrix should have the 9 elements. Now the order of the matrix is 9, and now make the two columns minus and cofactors. First we look to the minus. Since m11, so the minus for first element, that's 2. So 2 is coming in this column and this row. So leave this column and row. Remaining elements are 0, 4, 5, and minus 7. Solve this determinant. 0 into minus 7 is 0. 0 minus 20, so minus 20. So you got the minor of 1 element, that's for 2, is minus 20. Next, minus for A12, that means this minus 3. So leave this column, leave this row. Remaining elements are 6, 4, 1, minus 7. So 6, 4, 1, minus 7, write down in the determinant form and solve this determinant. So 6 into minus 7 is minus 42, minus 1 into 4 is 4. So minus 2, minus 42, minus 4 is minus 46. Similarly, I have to find the minus of 5. So leave this column, leave this row, you get 6 into 5 is 30, minus 1 into 0 is 0. So 30 minus 0 is 30. Next, suppose I have to find the minus of 6. 6 means M2, 1. That means second row and first column element. So we have to leave this column and this row. That means 6 is lying in this row and this column. So remaining elements are minus 3, 5, 5 and minus 7. So M21, we have to leave this row and leave this column. And remaining elements we have to write in the determinant form. So it will be minus 3, 5, 5 and minus 7. So similar way, minus 3 into minus 7, that's 21. Minus 5 into 5 is 25. So you got minus 4. So in this way we have to find the minus and cofactors of minus of all the elements. Suppose I have to find the minus of 7. That means your M33, that's last element. This 7 lies in the last row and the last column. So this 2 we have to leave it, and elements, remaining elements are down in the determinant form. 2 minus 3, 6, 0. So the minus of element, that's minus 7. This element lies in third column and the third row. So it is M33 we are going to find out. So as usual, this column element and this row element we have to leave. And the remaining element 2, minus 3, 6 and 0. We have to write down that in the determinant form. So here is element M33. So that's nothing but the 2, minus 3, 6 and 0. So if we solve this one, I am getting the 18. So in this way we can find the minus of the element. So minus is okay now. Now cofactors. Remember, same thing. Cofactor, this minus 1 is going to be same throughout. This minus 1 to the power of 1 plus 1. Why it is 1 plus 1? Because the position of this element is first row and first column. So 1 plus 1 into minor of first element, that's minus 20. So minus 1 to the power of 2, that means 1. 1 into minus 20 is minus 20. So this cofactor is nothing but multiplying the minor with respect to the minus 1 to the power. That's all. And this power depends on the position of the element. Now suppose I have to find the cofactor of minus 3, that's 1, 2. So minus 1 to the power of 1, 2. And minor of 1, 2, that's minor of 1, 2, already we found out minus 46. Just multiply this, we will get the cofactor. Similarly, suppose I have to find the minor of 0. The 0 lies in the second row and the second column. So I have to get the A22. So this is A22. That means minus 1 to the power of 2 plus 2 and minor of A22 element. That's minor of 22 elements is minus 19. Minus 19 into 1. So in this way we can find the minus and cofactors of all the respective elements. Suppose I have to find the cofactor of 5. So minor of 5 is already been found. That means minor of the elements A32. So minor of A32, that's nothing but this element. This 5 lies in third row and the second column. So this and this we have to leave 2, 5, 6 and 4. So 2, 5, 6 and 4 we have to write down in the determinant form, and then we have to find the minor. For cofactor, this minus 1 is same, minus 1 to the power of 3 plus 2 because it lies in third row and second column into minor of A32. So this is minus 1 into minus 22. So it is going to be 22. So find out all the elements of all the minors of each elements. So in this way we can find the minus and cofactors of the elements. This is the next topic, adjoint and inverse of the matrix. This is also important topic, so you will find the sums from these topics for the exams. For finding the solutions as the adjoint or inverse, first few conditions we have to satisfy. first we have to check the determinant is singular or non-singular. Now what is singular and non-singular is, find the determinant of determinant, expand it, and check the answer is coming 0 or not. If the answer is not coming 0, that means the determinant is non-singular and we can find the A inverse. That means inverse of the determinant we can find. But suppose if you expanded the determinant and the answer is coming 0, then respective determinant is the singular and we cannot find the inverse for the particular determinant. So these are the two cases we have to first see whether the determinant is singular or the non-singular, and it depends on whether the answer is 0 or the non-zero. Now when we were studying about the finding the inverse by elementary transformation, I told you that was the first method and the second method. Second method is like A inverse is equal to adjoint of A upon determinant of A. That means to find the A inverse, we require the adjoint of the matrix and the determinant of matrix. So whenever they are simply saying to find the inverse of the matrix, then just find the adjoint and then the determinant. Divide this both, you will get the inverse of the matrix. But if they say find the matrix by inverse by elementary transformation, then we have to use only elementary transformation method. So to understand it better, I have given one example here. So this is the matrix they have given and they asked to find the inverse. We know that finding the inverse, we want the adjoint of it and the determinant of it. So we'll find this first two. So I will find out the determinant first. I have expanded the given determinant, and then given matrix I have I will find out the determinant of the matrix, and then this is what is coming is equal to 10. That's not equal to 0. That means this is a non-singular. That means we can find the inverse of the matrix. Now the next step is we have to find the minus and cofactors. Again, minus, as I explained in the last slide, we have to find the minus of each element. So minus of first element 1 1, that is element of 1. We have to leave the first column and first row. Remaining elements are 2, 4, 0 and 5. Expand it. 10 minus 0 is a 10. Similarly, M12, leave the first row and the second column. Remaining elements are 0, 4 and 0, 5. Expand it, you will get the minor. Similarly, for the M13, M21, M22, you have to find all the minors of the elements. Then cofactors also same thing. Suppose I have to find the cofactor of 1 1, first element, then minus 1 is going to be same 1 plus 1 because it lies in the first row and the first column into minor of first one. So this is 1 into 10, it will be 10. Suppose you have to find the cofactor of second element which lies in the first row and the second column, then it will become minus 1 to the power of 1 plus 2. 1 indicates the row position and 2 indicates the column position into minus of the second element. Minus of the second element is 0. 0 into minus 1 is 0. So it will be 0. Similarly, you have to find all the cofactors of the elements. Now after finding the cofactors, for all the cofactor elements, you have to make the determinant. So 10 0 0 will be the first row, minus 10 5 0 will be the second row, and 2 minus 4 2 will be the third row. Now take the transpose of this matrix, you will get the adjoint. So transpose means what? Converting the rows into columns. Suppose first row is 10 0 0, make it column 10 0 0. Second row is minus 7 5 0, so it will become the it should be minus 10 here. It should be minus 10, sorry. So it will be second row minus 10 5 0, so it will be column minus 10 5 0, and the third row 2 minus 4 2, so it should be the third column. So 2 minus 4 2. So after taking the transpose, I will get the adjoint. Remember, cofactor we have to find out, cofactors determinant we have to take, and determinant transpose will give the adjoint. So we got the determinant also, previously we found out, and even we got the adjoint also. So both the things we got. Then inverse formula we know, adjoint of A upon determinant of A. So determinant was 10, so 1 by 10 into adjoint, then just multiply the 1 by 10 to each element, you will get the finally the answer, and this answer is nothing but the inverse. So by finding the adjoint, and by finding the determinant, we can find the inverse, because inverse formula is adjoint of A upon determinant of A. See the second example to find the inverse by using the formula, because formula is A inverse is equal to adjoint of A upon determinant of A. So first we have to find the determinant of it. So determinant, so 1 into bracket of this into this, cos alpha into minus cos alpha is minus cos square alpha, minus sin alpha into sin alpha is sin square alpha. This is plus 0, so minus 0. Anyways, is not going to matter anything because 0 into 0 is 0. So this is going to be 0 completely. Take the minus sign common, it will become cos square alpha. This minus is going to be changed plus because I took its minus common. Cos square alpha plus sin square alpha is 1. So 1 into minus 1 is minus 1. And again, it is a non-singular matrix because answer is not coming 0. So A inverse we can find out. Again, similar methods. Again, we have to find the minus. Again, we have to find the cofactors of everyone because we have to get the adjoint. So minus of 1 1 means this we have to leave, this we have to leave, and these 4 elements we have to write down in the determinant form. So cos alpha minus cos alpha into minus cos square alpha, sin alpha, sin square alpha, but in between minus because we are minusing multiplication of this and multiplication of this. So minus cos square alpha minus sin square alpha, again take minus sign. After taking the minus sign, bracket mein aayega cos square alpha plus sin square alpha, and that is 1. So 1 into minus is minus 1. So we got the minor cofactor ke liye again same thing, minus 1 is a common, so same for all. So minus 1 to the power of 1 plus 1, that means it lies in the first row and first column into minor of first element. So minor multiply and then we will get the answer. So minor is minus 1 into 1, so it will be minus 1. Similar thing, we have to find the minus of each element which is present in the matrix, and again we have to find the cofactors of each element as we discussed in the previous slide. So find the minus cofactors. Once you get the minus and cofactors, the next step is we have to find the matrix of all the cofactor elements. So here I got it, all the cofactors. I found one matrix. So these are the cofactors I got. Minus 1 0 0 0 minus cos alpha minus sin alpha 0 minus sin alpha cos alpha. Take the transpose of it, that means rows into columns converted. I will get the adjoint. Once you get the adjoint, use directly formula. A inverse is equal to 1 by determinant of A into adjoint of A. Adjoint of A already we know, determinant already we know, minus we got it. Just multiply it inside and get the final inverse answer. So next example we'll discuss. See, again matrix they have given and they asked you to show that a cube minus 6a square plus 5a plus 11i is equal to 0. So this is the first sub question, and then again they asked in the same question, find the A inverse. That means we have to show that first and then we have to find the A inverse. Now first I have to find the A cube value. A cube value means this matrix I have to multiply 3 times. So first I will find the A square, so A into A. So how to multiply, already I explained. First row into first column will give the first element, row element. First row into second column will give the second row element. First row into third column will give the third row element. 1 into 1, that's 1. 1 into 1, that's 1. And 1 into 2, that's 2. That means every element of row we have to multiply with the every element of column. So that will give the first element. Every element of first row and every element of second column will give the second element of row. Every element of first row and every element of third column will give the third row element. So we have to multiply all the rows and all the columns with respect to each other. That means each row of first matrix with each column of second, then I will get the respective elements. So after addition of all this and simplification, I got this a square value, but I need a cube. Then this a square value into a will give the a cube value. So this is a square into a value. Again same thing, multiply first row into first column, first row second column, first row third column, again second row first column, second row second column, second row third column, again third row first column, third row second column, third row third column. After multiplying, we'll get the determinant matrix like this. So this is the a cube value. So now this is the equation already they have given. We have to prove it is equal to 0. So I will take the LHS. Then this is a cube value minus 6 into a square plus 5 into this plus 11 into I. I means identity matrix. This value we know already, 1 0 0 0 1 0 0 0 1. So this is matrix, take it as it is. Multiply 6 inside. So minus 6 into 4. Don't multiply minus 6, keep minus as it is, and then multiply with the 6 only. So 6 into 4, 24, 6 2s are 12, 6 1s are 6. So multiply everything, here also 5, here also 11, and ultimately add everything. 8 minus 24, because minus sign is here, so 24 is going to be minus 24 plus 5 plus 11, then 7 minus 12 plus 5 plus 0. So we have to add all the respective elements, and then finally you have to simplify, and then you will get the answer is equal to 0. 0 comes means your answer is proved. What you want is this is equal to 0, that we got it. Now this is the first question, first of questions we proved. Next we have to prove is find the A inverse. Now this is the equation they have given. Remember, for finding the A inverse, we know that adjoint of A upon determinant of A. Then we have to find the minus and cofactors and all kind of things. So they asked in second sub question, they asked to find the A inverse. So instead of finding adjoint and then determinant, what we can do is take this equation and then multiplying A inverse to both the LHS and RHS. Means this is also I will multiply with A inverse and 0 also with the A inverse. Anyways, this is not going to change anything. Now A inverse, so A inverse into A cube, like 1 by A into A cube. So A cancel, it's a square. Again this is inverse into A square, so 1A will be cancelled, so A into A inverse is I. We know that's identity, we noted down. So this is 5I. 11 A inverse into I. Any matrix you are multiplying with I, you will get the same matrix. So A inverse. So 11 A inverse will be the finally is equal to 0 into this is going to be 0. I need A inverse, so keep this 11 A inverse in this side. Remaining all the things transfer to this side. So transferring this quantity is A square minus 6A 5Y. This side it will A square was positive, so it will become negative. This will become plus, and the 5Y will become minus. So I got 11 A inverse is equal to minus A square plus 6A minus 5Y. So A square value already I know, just substitute here. A value I know, I is, we know that 100,010,001, and then simplify, multiply this minus sign inside for to every elements, minus 4 minus 2 minus 1 3 minus 8 plus 14 minus 7 plus 3 minus 14, multiply 6 inside and then simplify, you will get this ultimately matrix. 11 A inverse is equal to this, transfer this 11 this side, it will become A inverse is equal to 1 by 11 into this matrix. Whether you keep it like this or just multiply this to the every element, we'll get this. So in this way we can find, in this way also we can find the inverse by multiplying what we did, original equation, multiply with the A inverse, simplify it, A square, A value already we know, I value we know, substitute, and then finally simplify. So this is the way we can find also A inverse. This is the last topic of 2 chapters what we have discussed. This is called the matrix method. This is the method we are using to find the solution of simultaneous linear equations. Now this is the linear equation. See, first of all they gave the 3 equations. Directly we'll go to the problem so you'll understand better. 3 equations they have given. 3x minus 2y plus 3z is equal to 8. 2x plus y minus z is equal to 1. 4x minus 3y plus 2z is equal to 4. So if 3 equations they are given, then you have to find the A matrix, X matrix and B matrix. Now this A matrix is what? All the coefficients of variables. See, 3, minus 2 and 3 are the coefficients in the first equation. 2, 1 and minus 1 are the coefficient in the second equation. 4, minus 3 and 2 are the coefficient in the third equation. So from this 3 you will get the 3 rows respectively. 3 minus 2, 3, 2, 1 minus 1 and 4 minus 3, 2. So I get the A matrix. X matrix is a column matrix of your variables. Your variables are x, y, z, so make the column matrix. And B is the column matrix of constants. Constant is what? That is the right hand side of your equal to. So there is 8, 1 and 4. So first step is to write down like this. Next, find the determinant. It's coming minus 17 of, let's say that's not equal to 0. That means non-singular, and then A inverse exists. This condition is not required. Anyways, you are not finding inverse to this one. So now if this, to find the system of linear equations, you have to note down this one. You have to write down like this: Ax is equal to b. So if I multiply A inverse to both the sides, even to the left hand side and right hand side, you will get A inverse into Ax and A inverse into b. So now A into A inverse into x and A inverse into B. This is nothing but I, we know, because we know A into A inverse ultimately will give the identity matrix. So I will write A into A inverse is nothing but I, this X as it is, and A inverse of B. So ultimately, if you multiplying any matrix with I, you will get the same matrix. So X is equal to A inverse of B. This is the ultimate equation we required. See, you have to remember only this equation. This is explanation not at all required. This is only for your understanding. So if you want to find the A inverse by using this solution, if they ask you to find the A inverse, then you have to satisfy this condition. Suppose you are taking this matrix, then again minus, again you have to find the cofactors by the same method whatever I explained, and then after finding the cofactors, you have to make all the cofactors you have to find out for each element. Then you have to make the determinant matrix of it. Then you have to take the transpose of it, that will give the adjoint. Once you got the adjoint, you know already determinant, just put it and then find the A inverse value. Now once we got the A inverse value, this equation already we proved. If you remember, in the last slide we proved is X is equal to A inverse of B. X is nothing but, you know, XYZ is equal to A inverse. A inverse means this is the value which I got. So substitute this value here. B is nothing but, in the first step we found out B means nothing but the column matrix of constant. Now we have to write down everything in this equation form. After that, multiply this and this. First row, first column, this element will get. Second row, first column, this element will get. Third row, first column, this element will get. Simplify this one, you will get this into minus 1 by 17. Multiply this, 17 by 17 1, 34 by 17 2, 51 by 17 3. So 1 2 3. So XYZ is equal to 1 2 3 ultimately you got. Since it is equality of matrix, that means X is equal to 1, Y is equal to 2, Z is equal to 3. This is nothing but the final values of your variables. So to understand the better matrix method, we have taken another one example. In this example, they have asked two sub questions. One is to solve and find the values of X, Y, Z by using the matrix method, and the next one to examine the consistency or not. Now consistency or inconsistency, we have to solve the determinant. Now form the matrices first. This is what the A, this is X, this is the B. So A matrix we can find by taking the coefficients. 2 1 1 will be the first row, 1 minus 2 minus 1 will be the second row, 3 minus 5, X is not there, so we can take 0. So 0, 3 and minus 5. X is a variable and B is the constants. Now find the determinant. After expansion of determinant, we will get the answer as 34. 34 is not non-zero value. If non-zero means equation is consistent. If determinant answer is coming non-zero, then consistent, and if it is 0, then it is a inconsistent equations. Now I told you this equations we derived in the last problem, but since we don't want proof, so just remember this one. X is equal to A inverse of B. X means XYZ. A inverse into B. B means this matrix we are writing here. Now A inverse we have to find out. How to find the A inverse? Again same methods. For finding the A inverse, we have to find the minors, then we have to find the cofactors of this A by the same method what we used in the previous slides. So first find the minors of each and then find the cofactors. Once we know all the cofactors of 9 elements, then ultimately you have to get the determinant matrix done. And this matrix transpose, that means converting the rows into columns, we will get the adjoint. Once adjoint is, you got the adjoint, then use the inverse formula. A inverse is equal to 1 by determinant of A into adjoint of A. So determinant is already we know 34. So 1 by 34 matrix of this you can write down because this is adjoint. Multiply this one. So this is nothing but the inverse you got. Now go to the previous equation. What is for this matrix method? X is equal to A inverse of B. X is XYZ. A inverse is already we got. B is constants. Multiply this and this. After multiplying this and this, you will get this matrix into 1 by 34. Multiply, get this calculations done. So you got 34, 17 and minus 51 into 1 by 34. So 1 by 34 into 34 is 1. 1 by 34 into 17 is 1 by 2. 1 by 34 into minus 51 is minus 3 by 2. So you got the values 1, 1 by 2 and the minus 3 by 2. So 1 by 2 minus 3 by 2 is equal to XYZ. Since it is equality, X is equal to 1, Y is equal to 1 by 2, Z is equal to minus 3 by 2. And in this way we can solve the every sum by using the matrix